Welcome back to the class on electrical vehicles and hybrid electrical vehicles. In this lecture, we are going to discuss about the classification of the fuel cells and what are the different fuel cells we are using for the electric vehicles and hybrid electrical vehicles. These are some of the fuel cells what we are using in electric vehicles and hybrid electrical vehicles. Alkaline, proton exchange fuel cell, direct menthol fuel cell, phosphoric acid fuel cell, molten carbonate fuel cell, solid oxide fuel cell. These fuel cells are highly depending upon what type of electrolyte is used in a fuel cell. Alkaline fuel cell. It is abbreviated as AFC. The aqueous solution of the potassium hydroxide is used as a electrolyte compared to the some of the other cells where acids are used as a fuel cell, which is caused to the corrosion for the positive electrode as well as the negative electrode. But in case of a potassium hydroxide, it is a non-corrosion for the both positive and negative electrodes. Alkaline fuel cell has a high efficiency up to the 60%. It requires a pure hydrogen gas as a fuel. It is operating at a temperature of 80 degrees. They are suitable for the vehicle application. Whatever the heat is generated in a alkaline fuel cell, that also we can use for the heating purpose. This temperature is not sufficient to use for the cogeneration process. Proton exchange membrane fuel cell, this is simply called as a PEM. Proton exchange membrane fuel cell is used as a solid electrolyte. It is also operating at a low temperature 80 degrees. Naphthalene is an example of the solid polymer electrolyte. So whenever you are using the electrolyte as a solid, there is no matter of corrosion for the positive as well as the negative electrode. But the electrical efficiency of the PEM is nearly 40%. It is a rugged construction. It is more suitable to use in electric vehicles. Nowadays, alkaline fuel cell and proton exchange membrane fuel cell are used in electric vehicle. Direct menthol fuel cell. The direct menthol fuel cell is resultant of research on using a menthol as a fuel that can be considered on board vehicle and reformed to supply the hydrogen to the fuel cell. The working temperature of direct menthol fuel cell is 90 to 120 degrees, such that internal reformation of the menthol into the hydrogen is possible. The electrical efficiency of the DMFC cell is a 30%. This type of fuel cell is still in a design stage because search for the good electrocatalyst to reform the menthol efficiency and to reduce the oxygen in the presence of the menthol is ongoing. Phosphoric acid fuel cell. It is the oldest fuel cell. It is nearly operating at 200 degrees. Because of this high amount of temperature, we can go for the cogeneration also. The electrical efficiency of this fuel cell is 40%. This type of fuel cells we are using for the high bulky transportation. Higher efficiency exists for the stationary application. Molten carbonate fuel cell, MCFC. The operating temperature of this molten carbon fuel cell is 600 degrees. Requires a carbon monoxide and carbon dioxide on the cathode side, hydrogen on the anode side. The efficiency of this fuel cell is nearly 50%, but excessive heat is generated, so that due to this excessive heat, you can go for the cogeneration. So because of this high temperature, this fuel cell is not suitable for the electrical vehicle, but it is more suitable for the stationary power generation. Solid oxide fuel cell. It is used the solid ionic conductor as an electrolyte other than the solution of polymer, which reduce the corrosion problem. It is also operating at a very high temperature. The original design using a yttrium stabilized zirconia as an electrolyte. It requires nearly the 1000 degrees temperature to operate. The efficiency of the cell will be lies between the 50 to 60%. Because of this high temperature, we can use the temperature for the cogeneration. The cogeneration is nothing but we are using the temperature to boil the water so that it is giving the steam with a high temperature and pressure we are using to generate electrical power. That type of generation is nothing but a cogeneration. It is a good choice of the vehicle application. It is more suitable to generate a power at a stationary level because the more amount of temperature is generated. Summary of the fuels. So these are the different fuel cells what we have studied up to here. These are the fuels what we have used. These are the different electrolytes for the different fuel cells. These are the different operating temperature. These are the different efficiencies of a fuel cell. These are the different applications where we are using the fuel cell. Thank you very much. If you have any doubt, can ask me, or you can ask in the comment box of my YouTube channel, so that I'm always welcome to answer all your questions.